Hello friends, welcome to my channel. Let's have a look at the newly appeared problem. Problem 2431. Maximize total tastiness of purchased fruits. In this video, we are going to present a solution based on dynamic programming. So we are going to use memoization. So first, let's roughly look at the problem. So we are given two non-negative integer arrays. One is price and the other is tastiness. Both arrays have the same length m. We are also given two non-negative integers, max amount and max coupons. So here, price I describes the price of the ice fruit, and tastiness I describes the tastiness of ice fruit. So we want to purchase some fruits such that the total tastiness is maximized and the total price does not exceed max amount. Additionally, we can also use a coupon to purchase fruit for half of its price. So here is rounded down to the closest integer. So we can also use at most this amount of coupons. So our task is to return or find the maximum total tastiness that can be purchased. So note that we can purchase each fruit at most once, and also we can use coupons on some fruit at most once. So these are the main statement of the problem. So let's also look at the constraint. First, the length of the two arrays is bounded below by 1, that is not empty, and bounded above by 100. And the last two constraints are on the range of elements in price, in tastiness, and the range on max amount and max coupons. So with that said, we are ready to analyze the problem. So here there are two examples given, so you can try to interpret the output according to the explanation given. So we are not going to details for that. So here let's look at our solution. So what we want to store or track here is the total tastiness we can get. So let's denote it by f. So here f is a function of the money we have and the number of coupons and how much of the information we're going to use. So here actually we can understand this I as an index. So the right hand side can be interpreted as, this is one way of doing the interpretation. So it's the maximum tastiness we can obtain if we use this amount of money and this number of coupons and using the fruit starting from index I and onwards. So here our goal is to find f max amount, max coupons, and then using all the given fruits. So here actually we can easily get the DP update rule or recursion relation. So if we denote P as the price and index I, and T as the tastiness and index I, then this function f money and coupons and I, so this is the general case. So we need to treat some edge cases or edge conditions when we write the code. It's a max of this three items. So the first item, so we minus the amount of price, and then we look at the next. So but we add T. So T is tastiness. So here it means that we try to buy but without using coupon. So if we buy, our money is decremented by P, and because the bought fruit has tastiness, so we increment the tastiness by T. So this is the first item. The second item is that we try to buy but with the coupon. So here if we use coupon, we can use half of the price. So notice that by the problem assumption, so we need to round it down to the closest integer. So here the money subtract is P integer division by 2. So in this case, as we have used one coupon, so we are going to decrement the amount of coupon by 1. And then we are going to go to next step or look at next. So here we also increment the tastiness. So this is the second item. The third item is that we do not buy this specific fruit. so we go to next index directly. So this is the one way of understanding of this relation. So with that said, actually we can write code without much difficulty. So here the comment is that it might be useful or good practice to review the 0-1 knapsack problem or its variants. So this is actually related to this problem. So in this problem, if we do not consider using coupon, so we can try to use the 0-1 knapsack problem idea. So with that said, so we are going to write the code. So here, let me because here we are going to use memorization, or we can use some decorator. So first, let me write the hyperfunction. So we are going to call this function f, and we interpret this f as total tastiness. So we are going to define f. So it's a function of money and number of coupons and the current index we are looking at. So we're going to return the total tastiness. So first, so let's consider some forbidden case. That is, if money is less than 0. In other words, we do not have money, or we have coupon. It's also negative. So in this case, we're going to penalize. So we're going to return float, see, negative infinity. So this is the one case. So another stop condition is that if I equals the length of the price. So actually we can first track this information here, just for convenience. So we are going to use n equals the length of price. So if I equals n, or the money equals 0. So this is the stop condition, right? So we're going to return 0. So this is we can also regard this as the base case in the DP, right? So with that said, let's track the information for the current price and the current tastiness. So we can write like this: price, the current index, and tastiness. So it's at index I. And then we're going to consider this part. So we're going to return this one, right? So what we're going to do is that, so we're going to return the max of the 3 different options. First is that, so we buy this fruit, and then without using coupon. So coupons does not change, and then we go to next. But in this case, we increment the tastiness by t. So another option is that we use coupon. So we're going to minus p integer division by 2, and then the coupon amount is decremented by 1, and then we go to next. So in this case, the tastiness is also incremented by 1. So another case is that we do not buy this fruit. So we're going to have money does not change, and coupons and does not change. Then we go to next. So that's the 3 terms. So this is the hyperfunction we write. So next we're going to do the return, function call and return. So we're going to return this part. Our goal is to return maximum amount and max coupons, and it starts from index 0. So this actually forms a full solution format. Let's do some test case. So yeah, this passes the first example. Now let's look at the generic case. Oh, time limited. So here, yeah, that's the thing. So here we are going to use cache. We are going to use least recently used cache. So here I'm going to set the max size to be none. So if this is the case, now let's do the test. Yeah, this passes the all the examples. So now, in order to dive deeper, so I'm going to write another form of this same solution. So here, let me copy this function signature, and I'm going to mark this one as v1. So what we are going to do is that we can first so the second format is essentially the same as the first one, but we do not explicitly use the cache here. So we do not use the decorator, to be more precise. So here, let's write this n to be the length of the price. So this is the information we want to first get, and then we're going to introduce a dictionary to store all the information. So the cache. So next we are going to write the function. So we're going to write the function similar as above. So money, number of coupons, and index, right? Same interpretation, but slightly differently. So we're going to say first the impossible case, or n coupons less than 0. So in this case, we are going to return negative infinity, say. This is the one case. Another case is if I equals n, or money equals 0. So we're going to return 0. So another case is that, so we're going to say if money in coupons and I in the cache. So in other words, if we use the cache language, so this is the hash hit, so we're going to return cache with this key, right? Let's copy this one. Otherwise, so we consider the case here. So let me copy this part. What we want to do is this. So we're going to set the cache at this key, right? So sorry, that's too much. So let's copy it again. So let's copy this part. So we're going to do things like this. Cache. So money and coupons and I equals this part. The max of this items. So let me make sure they are okay. All right. So now let's put it here. Right. So we have this one, and then we are going to return this part. Right. So this way, actually, so first we write the function. So we use a specific storage or cache. So then we're going to return this one. So no, let's not return this one. Let's call this function. Let's see. All right, so this is the second format. So let's first do a special case check. Yeah, it passes the first one. So now let's do a generic case check. All right, it passes all the cases. So yeah, I guess that's about it for this specific problem. So here we actually shared that solution based on DP. So we used memorization. So essentially the two formats presented here are the same solution. But this kind of details can be important in some cases. So with that said, I guess that's about it for this video. Thank you very much.